Okay, one of the main uses of logarithms is to help us solve equations. And this first video is about solving equations with index form. Okay, let's go. Okay, all the equations that you can see, 1, 2, 3, 4, are in the form log BAP. All right, so they're all base to the power equals the answer. And I'm going to show you how to do the first two, and then you can have a go at doing 3 and 4. So what we're going to do to both sides of the equation, it's an equation, so we do it to both sides, is I'm going to take logs of both sides. So if you see an equation in index form, you take logs to both sides. Now, base, what base am I using? Well, I'm actually using base 10. And the reason I'm using base 10 is because base 10 is in the calculator, but I could take logs of any base. I could take logs of base 3 to both sides, or logs of base 5 to both sides, or I could choose my base. But log 10 seems sensible as I have log 10 in my calculator. And of course, good mathematicians can't be bothered to write the 10, all right? So I'm actually just going to scrap them out again. So I've taken logs to base 10 of both sides. Now, in the last video, we talked about this power rule, and you can see that I've got a little power here. I'm using my power rule. I'm going to move him down in front. So I'm going to end up with x log 2 equals log 3. And then what I'm going to do is I'm going to divide both sides by log 2. So I'm going to end up with log 3 divided by log 2. Now, if you grab your calculator and we type in log 3, I'm going to press equals and then divide by log 2. And then I'm going to press equals. My calculator tells me that the answer is 1.584962501, but I'm going to round it to 1.584. Okay, let's do the second one. So it's exactly the same process as before. We're going to take logs to both sides. So log 3 to the x equals log 10. And then we're going to move that x down in front. X log 3 equals log 10. And then we're going to divide. So x equals log 10 divided by log 3. So x equals, on my calculator, log 10 equals divided by log 3 equals, and my calculator is telling me 2.0959. Okay, easy. Right, you guys have a go at 3 and 4. Okay, I'll go through the answers to 3 and 4. So we're going to go log 4 to the x equals log 5, running out of space. Move him down, x log 4 equals log 5. So x equals log 5 divided by log 4. So I reckon log 5 divided by log 4, I'm getting 0.602. All right, that's for question 3. Question 4. We're going to do log to both sides, so log 6 to the x equals log 7, and then we're going to move him down. In fact, I'm going to do this in one go, so it's log 7 over log 6. So log 7 divided by log 6, I think we're getting something like 1.086. Rubbish pen run out. Okay, easy. Okay, here comes some even harder index equations. I just want you to watch what I'm doing because there's some quite clever tricks in these. The first thing that I'm going to do with this one is I'm going to move the 56 over to the left. And then it looks like this quite strange thing that I'm going to refer to all year as a hidden quadratic. Okay, so a hidden quadratic. How is it possibly a hidden quadratic? Who knows? Right, so what we're going to do is this is the technique for if you think you've got a hidden quadratic. We're going to let y equal the middle. Doesn't always work, but it often works. Let y equal the middle, and then what we're going to do is we're going to square it. So we'll end up with an expression for y squared equals. So let me show you what happens. So first of all, with the middle is y to the y equals 7 to the x. Then we're going to square it, which gives us y squared equals, okay, 7 to the x times 7 to the x is 7 to the 2x. We would add them together, not 49, no 49 or rubbish or anything like that. So we're going to get 7 to the 2x, and then we're going to rewrite this whole equation here using our y's. Okay, so instead of 7 to the 2x, we've got y squared. Instead of 7 to the x, we've got plus y, and then we've got minus 56. Right, that is now a really easy quadratic that we can factorise. It's going to be a 7 and an 8, isn't it? Plus 8 minus 7, and therefore we've got y equals minus 8, or y equals 7. Now, of course, we're not solving it for y's, we're solving it for x. So we're going to replace the, what was our y? Our y was 7 to the x. We're going to replace it back down. So 7 to the x equals minus 8, or 7 to the x equals 7. Now, this one's easy. X is just 1, isn't it? So one of my answers is x is 1, bingo. But this one is harder. So if we're not quite sure what this is, we're going to have to just take logs of both sides to solve it. So log the left, log the right. Okay, move him down, so he's going to come down. X log 7 equals log of minus 8, and therefore x is the log of minus 8 over the log of 7. Now if you try and put the log of minus 8 into your calculator here will say error. It won't like it. So there are basically no solutions for this bit. We would write no solutions. Now why that works, I'm just going to very quickly show you this graph. This is the log graph here at 1, and there are no, if you're ever trying to do the log of a negative, it won't work. All right, you won't need to know about that though until the second year. So now what we'll do is we'll have a look at this second one. He's got a bit squeezed under the bottom of the page. We're going to look at this second one. He's a bit nasty, so I'm going to give myself a bit more space. Okay, here he is. This is a bit of a killer, this one. The first thing I notice is that I haven't got all the same base. This is 3. Let's go back to my pen. This is 3, this is 3, this is 3, but this one is 9. So the first thing that I'm going to do is I'm going to try and change that 9 to the x into base 3. So I know that 9 is 3 squared, so that's the 9 part, and I know he's raised to the x. And I call this a power to a power rule. And with a power to a power rule, I'm timesing. So actually that 9 to the x is the same as 3 to the 2x. Okay, let's write the rest of it out like so. Now, I'm not really sure what this is looking like. It's just looking a little bit horrific. But I'm going to kind of try and apply the same principles. Now, there's not really a middle, but I'm going to kind of just hone in on this bit. So I'm going to say to myself, let y equal 3 to the x, and then I'm going to just kind of have a play around with it. So that's sort of my middle, and then I'm going to square it, which gives me y squared equals 3 to the 2x. Why does that work? Because 3 to the x times 3 to the x, I would add the powers and I would get 3 to the 2x. So that's got this bit here sorted, and it's got that bit sorted. But I've still got this bit here. Now this is really clever. So what I'm going to do is I'm going to write out one of my statements above. I'm not really quite sure which one, but you'll get used to this. So I'm going to write out y equals 3 to the x. And then I notice that what I've got here is I've got a minus 3 to the x plus 1. So what I'm going to do is I call it tweaking it. I'm going to times both sides by 3. Now I chose this one, but I could have tweaked this one. I could have fiddled around and see if that worked, but I just chose one of them and tweaked one of them. Now let's see what we're ending up with. We'll end up with 3y equals, now there's a power on here which is a 1, and therefore if we times those 3's together we add the powers, which gives us 1 plus x. So we've done it. Look, we've done that one now. Perfect. So what we're going to end up with is, in all this big mess, 3 to the 2x minus 3 to the x plus 1, I'm just writing him out again, minus 3 to the x plus 3 equals 0. So 3 to the 2x, let's find him. 3 to the 2x was that, so that's y squared. 3 to the x plus 1 was that, so that's minus 3y. 3 to the x, where was he? Over here, so that's minus y, plus 3 equals 0. Okay, that is now not looking so bad. So y squared minus 4y plus 3 equals 0. I think it's going to be an OK quadratic. Here's my pen having a bit of a nightmare. So it's going to be an OK quadratic. It's going to be a minus 1 and a minus 3. So I think that my y is coming out as 1 or my y is coming out as 3. Okay, so I'm getting out y as 1 or I'm getting out y as 3. And we're going to obviously not solve it for y's, we're going to solve it for x's. So we had y equals 3 to the x, so 3 to the x is 1, or 3 to the x is 3. And in fact, this one I can just do in my head. It's just x must have to be 1 and x must have to be nothing. But if I couldn't do it in my head, I'd have to take logs of both sides to solve them. Okay, that's it.